My dear students, welcome back to our channel. In this video, I will be explaining the MBA second semester subject Quantitative Analysis for Business Decisions as prescribed by JNTU and other universities of Telangana. We will go through the important questions and answers one by one. Let's begin with a quick revision. Unit 3 first important short question is: define an assignment problem. An assignment problem is a type of operations research problem where the goal is to assign a number of tasks, jobs, to the same number of resources, workers, machines, etc., in the best possible way. The aim is usually to minimize cost or time or to maximize profit or efficiency. In this model, each job must be assigned to exactly one person, and each person can handle only one job. It is a special case of the transportation problem where supply and demand are both equal to 1. Example: suppose there are 3 workers A, B, C and 3 tasks T1, T2, T3. Each worker takes a different amount of time for each task. By preparing a cost matrix and solving it using methods like the Hungarian method, we can find the assignment that takes the least total time. Easy to remember, assignment problem is equal to who should do what at minimum cost or maximum profit. Next important short question is: 2. What is an unbalanced assignment problem? An assignment problem normally has the same number of jobs and workers, for example, 4 workers and 4 jobs. But when the numbers are not equal, it is called an unbalanced assignment problem. In such cases, we cannot directly apply methods like the Hungarian method because every worker must be matched with exactly one job. To solve this, we make the problem balanced by adding dummy rows or columns with zero cost or profit. Example: suppose there are 3 workers A, B, C and 4 jobs J1, J2, J3, J4. Since workers' jobs, we add one dummy worker D with zero cost. Now we have 4 workers and 4 jobs. The dummy worker represents the extra job left unassigned. After balancing, we can solve using the Hungarian method. Easy to remember. Equal jobs is equal to balanced. Extra jobs workers is equal to unbalanced, add dummy row column with zero cost to balance. Next important short question is: 3. What is multiple optimal solution in an assignment problem? Multiple optimal solution in assignment problem. In an assignment problem, we usually get one unique optimal solution after applying methods like the Hungarian method. But sometimes, we may find 2 or more equally best solutions with the same total cost or profit. This situation is called a multiple optimal solution. It means the manager has flexibility to choose any of those solutions, as all of them give the same best result. Example: suppose 2 workers A, B are to be assigned to jobs J1, J2. If A does J1 and B does J2, total cost is equal to 10. If A does J2 and B does J1, total cost is equal to 10. Here, there are 2 different assignments, but both give the same minimum cost, 10. So, we have multiple optimal solutions. Easy tip: one best solution is equal to optimal. 2 or more equally best solutions is equal to multiple optimal. Next important short question is: 4. Define unbalanced supply and demand in a transportation problem. Unbalanced supply and demand in a transportation problem. In a transportation problem, the total supply from factory's warehouse must be equal to the total demand from market's customers. This condition is called a balanced problem. But if total supply is not equal to total demand, The problem becomes an unbalanced transportation problem. If supply-demand, some goods remain unused. If demand-supply, some demand cannot be fulfilled. To solve it, we make it balanced by adding a dummy source or dummy destination. Dummy destination when supply is more, to absorb extra supply. Dummy source when demand is more, to meet extra demand. Example. Total supply is equal to 150 units. Total demand is equal to 130 units. Here, supply-demand. We add a dummy destination with demand is equal to 20 units to balance it. Easy tip. Supply is equal to demand balanced. Supply is not equal to demand unbalanced. Next important short question is 5. What is degeneracy in a transportation problem? Degeneracy in a transportation problem. In a transportation problem, when we solve using methods like the northwest corner rule, WAM or MODI, we must have exactly M plus N1 allocations where M is equal to number of rows, supply points. N is equal to number of columns, demand points. If the number of allocations is less than M plus N1, the solution is called degenerate. Degeneracy makes it difficult to proceed with optimality tests because fewer occupied cells do not provide enough information. Example. Suppose there are 3 supply points, M is equal to 3, and 4 demand points, N is equal to 4. So, required allocations is equal to 3 plus 4 to 1 is equal to 6. If our initial solution gives only 5 allocations, then it is degenerate. To fix it, we usually add a very small value, epsilon, nearly 0, in an empty cell to complete the required number of allocations. Easy tip. Allocations M plus N1 degeneracy. Next unit 3. Long questions. First important long question is 1. Explain the Hungarian method for solving an assignment problem with example. Hungarian method for solving an assignment problem. The Hungarian method is a special technique used to solve assignment problems. It helps managers assign tasks, like jobs to workers, machines to projects, teachers to classes, in such a way that the total cost is minimum or total profit is maximum. It is called the Hungarian method because it was developed by Hungarian mathematician Egerveri. The method works step by step to simplify the problem into an easy form. Steps of the Hungarian method. 1. Form a cost matrix. Write the cost of assigning each worker to each job in a matrix form. 2. Row reduction. Subtract the smallest value in each row from all the values of that row. 3. Column reduction. From the new matrix, subtract the smallest value in each column from all the values in that column. 4. Draw minimum lines. Draw the minimum number of horizontal or vertical lines to cover all zeros in the matrix. 5. Test for optimality. If the number of lines is equal to number of rows or columns, an optimal assignment is possible. If not, adjust the matrix by subtracting and adding values, then repeat the process. Example. A company wants to assign 3 workers, A, B, C, to 3 jobs, 1, 2, 3. The cost matrix is Job 1 job to job 3. A 847. B 659. C 786. Step 1. Row reduction. Row A 8 to 4, 4 to 4, 7 to 4 is equal to 4, 0, 3. Row B 6 to 5, 5 to 5, 9 to 5 is equal to 1, 0, 4. Row C 7 to 6, 8 to 6, 6 to 6 is equal to 1, 2, 0. Step 2. Column reduction. From each column subtract the smallest value, we get more zeros. Step 3. Assignment. Now assign jobs to workers at zeros, A job 2, B job 1, C job 3. Total minimum cost is equal to 4 plus 6 plus 6 equals 16. Easy tip. Hungarian method is equal to row reduction column reduction cover zeros assign. Next important long question is to solve a maximization case in an assignment problem using the Hungarian method. Maximization assignment via Hungarian method. Idea: the Hungarian method is built for minimization. For maximization, first convert profits to costs, solve, then convert back. Example: profit matrix. Assign workers A, B, C to jobs 1, 2, 3 to maximize total profit. Job 1 job to job 3. A 876. B 697. C 768. Step 1. Convert to a cost matrix. Find the maximum profit is equal to 9. Cost is equal to max profit. A 989796 is equal to 1, 2, 3. B 969997 is equal to 3, 0, 2. C 979698 is equal to 2, 3, 1. Step 2. Row reduction. Subtract the row minimum from each row. Row A min is equal to 1, 0, 1, 2. Row B min is equal to 0, 3, 0, 2. Row C min is equal to 1, 1, 2, 0. Step 3. Column reduction. Subtract column minima. Kernel 1 values 0, 3, 1, min 0, no change. Kernel 2 values 1, 0, 2, min 0, no change. Kernel 3 values 2, 2, 0, min 0, no change. Reduced matrix stays 1 to 3. A0 1 2. B3 0 2. C1 to 0. Step 4. Cover zeros with minimum lines. Zeros at A, 1, B, 2, C, 3. We can cover all zeros with 3 lines is equal to order of matrix. So an optimal assignment exists. Step 5. Make assignments at independent zeros. Choose A1, B2, C3. Step 6. Convert back to profit and compute total. A1 is equal to 8, B2 is equal to 9, C3 is equal to 8. Total maximum profit is equal to 25. Why this works? Converting to costs lets us use the same Hungarian steps. Zeros represent best opportunities. Independent zeros give the optimal assignment. Memory hack. Max case convert, profit cost is equal to max profit, do Hungarian map back to profit. Shortcut mantra, max. Make it min, solve, map back. Next important long question is 3. Explain the traveling salesman problem, TSP, with a suitable illustration. Traveling salesman problem, TSP. The traveling salesman problem, TSP, is a famous problem in quantitative analysis. It asks, if a salesman has to visit a set of cities starting from his home city, visiting each city exactly once and returning home, what is the shortest possible route? This is important in business, logistics, and transportation because it helps save time, cost, and fuel. Example. Suppose a salesman must visit 4 cities, A, B, C, D, and return to city A. The distance, in kilometer, between cities is given below. A, B, C, D. A0 10 15 20. B10 0 35 25. C15 35 0 30. D20 25 30 0. Step 1. List possible routes. The salesman must start and end at A. Possible routes are 1. ABCDA 2. ABDCA 3. ACBDA 4. ACDBA 5. ADBCA 6. ADCBA. Step 2. Calculate distances. 1. A, B, C, D, A is equal to 10 plus 35 plus 30 plus 20 equals 95 km. 2. A, B, D, C, A is equal to 10 plus 25 plus 30 plus 15 equals 80 km. 3. A, C, B, D, A is equal to 15 plus 35 plus 25 plus 20 equals 95 km. 4. A, C, D, B, A is equal to 15 plus 30 plus 25 plus 10 equals 80 km. 5. A, D, B, C, A is equal to 20 plus 25 plus 35 plus 15 equals 95 km. 6. A, D, C, B, A is equal to 20 plus 30 plus 35 plus 10 equals 95 km. Step 3. Select the shortest route. The minimum distance is equal to 80 kilometers. So, the optimal routes are ABDCA, ACDBA. Why it is useful? TSP helps in courier delivery routes, transport scheduling, supply chain planning. Memory tip. Think of TSP as one salesman, all cities, one visit each, shortest round trip. Next important long question is 4. Find the initial basic feasible solution, IBFS, of a transportation problem using A. Northwest corner method, B. Least cost method, C. Vogel's approximation method. Problem balanced. Costs unit. D1 D2 D3 supply. S1 8 6 10 20. S2 9 7 4 30. S3 3 4 to 25. Demand D1 is equal to 15, D2 is equal to 20, D3 is equal to 40, total supply is equal to total demand is equal to 75. A. Northwest corner method, NWCM. Rule: start at top left, allocate as much as possible, move right down when a row column is satisfied. Allocations. S1D1 is equal to 15, S1D2 is equal to 5, S2D2 is equal to 15, S2D3 is equal to 15, S3D3 is equal to 25. Total cost: 15 times 8 plus 5 times 6 plus 15 times 7 plus 15 times 4 plus 25 times 2 is equal to 365 rupees. Why useful? Fast, no cost look just fills corners. Limitation: may be far from optimal. B. Least cost method, LCM. Rule: always allocate first to the lowest cost cell, break ties logically, then repeat. Cheapest cells in order: S3, D3 is equal to 2, S1, D2 is equal to 6, S2, D1 is equal to 9. Allocations. S3D3 is equal to 25, S1D2 is equal to 20, S2D1 is equal to 15, S2D3 is equal to 15. Total cost: 25 times 2 plus 20 times 6 plus 15 times 9 plus 15 times 4 is equal to 365 rupees. Why useful? Uses costs, often better than NWCM. Limitation: still greedy, not always near optimal. C. Vogel's approximation method. 1. Rule: for each row column, compute penalty is equal to smallest cost second smallest. Pick the highest penalty line, allocate at its cheapest cell, repeat. Allocations: 1. Optimal IBFS found. S1D2 is equal to 20, S2D3 is equal to 30, S3D1 is equal to 15, S3D3 is equal to 10. Total cost: 20 times 6 plus 30 times 4 plus 15 times 3 plus 10 times 2 is equal to 305 rupees. Why useful? Considers regret penalty. So IBFS is usually closest to optimal among the three. Quit memory hook. NW, fill corners, don't see price. LC, pick the cheapest cell each time. WAM, choose the line with highest penalty, then the cheapest cell. Summary, for this case, WAM, 305 rupees, beats LCM, 365 rupees, and NW, 365 rupees, giving a better starting solution for the Modi stepping stone optimality test. Next important long question is 5. Explain the Modi method for testing optimality in a transportation problem with example. Modi method, modified distribution method. The Modi method is used in a transportation problem to check whether the solution we found from NWCM, LCM, or WAM is optimal or not. If not, it also shows how to improve it. It is more systematic and less time-consuming than the stepping stone method. Steps of Modi method. 1. Find an initial basic feasible solution, IBFS. Use NWCM, LCM, or WAM. 2. Calculate row, U, and column, V, potentials. For allocated cells, use Sig is equal to UI plus Vj, where Sig is the transportation cost. Assign U1 is equal to 0 first, then solve equations. 3. Find opportunity cost, is. For each unallocated cell, Ij is equal to Sig UI plus Vj. 4. Check optimality. If all is greater than or equal to 0, the solution is optimal. If any is 0, the solution is not optimal. Improve solution. 5. Improve allocation. For the most negative Ij, form a closed loop. Adjust allocations, plus and recalculate until optimality is reached. Example. Problem. D1 D to D3 supply. S1 to 3 120. S2 5 4 8 30. S3 5 6 8 25. Demand D1 is equal to 10, D2 is equal to 30, D3 is equal to 35. Step 1. IBFS using WAM. S1 D3 is equal to 20, S2 D2 is equal to 30, S3 D1 is equal to 10, S3 D3 is equal to 15. Total cost is equal to 20 times 1 plus 30 times 4 plus 10 times 5 plus 15 times 8 is equal to 290 rupees. Step 2. Find U and V. Take U1 is equal to 0. For S1, D3 is equal to 1 0 plus V3 is equal to 1 V3 is equal to 1. For S2, D2 is equal to 4 U2 plus V2 is equal to 4 U2 plus V2 is equal to 4. For S3, D1 is equal to 5 U3 plus V1 is equal to 5, etc. Solve all. Step 3. Find is. Suppose delta to 3 is equal to 2 negative. Step 4. Adjust allocations. Shift units along closed loop, reduce total cost. Step 5. Repeat until all delta greater than or equal to 0. Finally, we reach optimal cost lower than 290. Easy memory trick. Modi is equal to make optimum decision immediately. Check U plus V values, find delta. If all delta greater than or equal to 0, you are done. Thus, the Modi method is a fast way to test and improve solutions in a transportation problem.